Hello everyone. So in our previous video, we discussed about the rules related to big O notation. So now let's apply those rules and calculate the time complexity of a constant algorithm. So here you can see that let's say we are given this piece of code where we are getting two integers, we are doing the sum of it and we are returning the result. So here you can see that these are the line numbers here where second and third line are the statements which get executed. And here is a simple table provided with the line number and the operations getting performed on each line and the unit of time taken by each line. So here we start with the line number 2. So here we are simply taking in two integers, doing its sum and assigning it to the integer variable result. So if we apply the rules which we discussed in our previous video, so here first we are accessing x, so it will be one operation. Then we are accessing y, so it will be the other operation. Then we are doing the sum of it, so this will be one more operation. And then we are assigning it to the result, so this will be one more operation. So here we are simply performing 4 operations. And we also discussed in our previous video that these 4 operations will take 4 units of time because we are providing 1 unit of time to assignment to arithmetic operation if we are accessing any variable. So like that. So line number 2 takes 4 units of time to execute this statement. Now let's see for the line number 3. Here we are accessing the result, so it will be one operation. And then we are returning the result, so it would be the other operation. So there are total 2 operations. And we know that when we are accessing a variable and when we are returning, we provide 1 unit of time to one operation. So total it will take 2 units of time. And when we take the total time taken by this piece of code, it will be 4 plus 2, which is 6. And usually if we see, 6 is nothing but a constant, because here whatever value you take of x and y, it will always take a constant amount of time, which is 6. So here time taken is nearly equal to a constant amount of time. So similarly, if we see this piece of code, let's say we are passing in an array and we are passing in an index and we want to simply get the value stored at that particular index. So here you can see that accessing a value of an array from a particular index takes in a constant amount of time. So the time taken by this piece of code will be constant. Now irrespective of how many elements are there in this array, let's say if array has 1 lakh element, still it will take the constant amount of time. And if the array has 1 element, still it will take the same amount of time. So therefore this is a constant algorithm. So we simply denote the time complexity of such algorithm as O of 1, because this is the constant, and usually in big O terms we denote the constant by O of 1. And if we see the graph of this constant algorithm, so here you can see the x-axis denotes the volume of data. So here you can think of it as the number of elements in this array, and the y-axis denotes the execution time, which is the time taken. So here we already discussed that irrespective of number of elements or the volume of data inside this array, the time taken will be always constant. So we simply denote it as constant algorithm, which takes constant amount of time, even if the volume of data increases. So friends, in this video we discussed that how we can calculate the big O notation of a constant algorithm. I hope you like this video. Thanks, have a nice day.